Here is example number 6 on circles, and this will again be another example of completing the square. Get used to the air quotes, completing the square. All right, so much like the one we just enjoyed, this is just more practice. We want to manipulate this equation to look like this, and then it'll be a center radius equation, and then graphing it'll be very easy. So, as before, I would suggest we take the terms that have x in them and pull them off and leave a gap here to, ready, 1, 2, 3, complete the square. All right, and then on the y terms, these are the two terms that have y in them, and so we'll have them here, and then we'll leave a little gap there to, ready, 1, 2, 3, complete the square. All right, and I would also note on this one that the number negative 15 is already on the other side, so we don't need to move any constants out of the way. So here again, you're probably thinking to yourself, what is this complete the square that you speak of? Well, again, it's that little formula there, middle divided by 2 parentheses squared. Smart math people figured these things out, all right? And so the middle term, as far as the x is going to be negative 4. The middle coefficient, to be clear. So we've got the first term, the second, the middle term, and the third term. That after we pop that number in there, that's going to be the middle term, isn't it? That's the reference to middle. So, parentheses, negative 4 over 2 parentheses squared. I don't have a lot of space to do all the arithmetic, but that would be negative 2 in the parentheses, and negative 2 in parentheses squared is positive 4. I want to point out that any number in parentheses squared is always positive, plus 4. Add 4 to the left, add 4 to the right. Make sure you add that 4 to the other side of the equation as well, all right? And if all goes well, this will hopefully factor as the same expression twice. That's what we hope for. It's going to happen. Smart math people figured it out, okay? Middle here would be 12 over 2 parentheses squared. 12 over 2 is 6. 6 squared, 36. Pop a plus 36 in there. Pop a plus 36 over here. Make sure to do it to both sides. Whatever the formula creates on the left, make sure you do it to the right side as well. So on this side, it looks like we're left with 25. Just add the numbers. Now you go, man, I really hope, fingers crossed, I really hope that trinomial factors. I really hope it factors. Well, let's see. How about x minus 2, first outer inner last? Yeah! That's how it factors. And you know what? Not only did it factor, but they're identical! Isn't that the same quantity twice? Can't that be written as x minus 2 parentheses squared? Doesn't that look like the equation of a circle there? Yay! All right. Plus, oh man, I sure hope this thing factors, this trinomial here. Well, let's see. Look, you have the advantage of knowing that if you did it right, they should be identical, right? So anyway, with a little bit of trial and error, let's try y plus 6, y plus 6. Outer inner, 12y. Same expression twice. Y plus 6 parentheses squared. I would submit to you that through a little bit of algebra trickery, we took this original equation and manipulated to that. We used algebra to do this. That would be the center radius equation. So now we'll put this up in the box. As I'm doing so, I want to share with you, I do not, repeat, do not need you. I, in fact, don't want you to do all this work over here in the box. I've had people in the past who thought they were supposed to cram all that work into the box. And we have all this wide open space on the paper to do the completing of the square and everything. I had somebody one time get mad at me. You didn't give me enough room in the box to do the work. I don't want the work in the box. Do it on the wide open space. Transfer your answer into the box. Sorry, you're not my therapist. I'm still scarred by that experience. Kind of. All right. Now, and I should have had some graph paper ready to go, but oh well. But the hope would be that once we've changed that equation into center radius, you would go, well, that's called a center radius equation because it's very easy to identify the center and the radius from that equation. And this would be very similar now to example number 1. Have I mentioned, watch them in order. Okay, so the center, the x-coordinate, what would x have to be for that to equal 0? 2 minus 2. What do you have to put in for y to make that equal 0? -6. And we'll plot that point. 2, -6. And once again, same speech, you're going to have perfect graph paper and your circles will look way better than mine. How big should I make the circle? That's the radius. And again, I want to remind you that this number sitting over here is the radius squared, not the radius itself, so not in the box. How about underneath it? You say, well, you know what, if the radius squared is 25, then wouldn't the radius itself, when you square root both sides of that equation, be 5? So let's put radius equals 5 in the box. And then back to the graph, we'll go 5 units, left, right, up, down on the wall here, all right? So I count 5 boxes, 1, 2, 3, 4, 5. Go back to the center, 1, 2, 3, 4, 5. Go back to the center, 1, 2, 3, 4, 5. Go back to the center, 1, 2, 3, 4, 5 on the wall down here. Whoops. I wish I had more board space. My graph paper's over there off the camera. Boom. This doesn't look like a circle at all. I get it. Okay? Yours will. You'll have great, wonderful, absolutely perfect graph paper to put yours on. Right? Okay. There's that. I missed you guys. I hope everybody's doing okay. Please take care of yourselves and your families. All right, we'll do one more of these.